is kinetic energy. Windmills are an example of this. Okay? Biggest thing with the kinetic type of energy, right, is kinetic is movement. Right? So the movement of the object is creating the energy. Okay? Anyone think of any other examples of something that is kinetic energy?
Windmills. What about the little hamster?
Great example, Riley. Tanner?
A waterfall.
Ooh, waterfall, yes, yeah. Like any sort of like, when they do a waterfall and then they power it with basket. Tanner, was my name.
Would the little hamster thing count? Like the hamster
Hamster wheel.
Yeah. If you hooked up your hamster and used it to harness power, sure. I've always thought that they should hook up a generator in the fitness center so every time we're biking, we can generate power.
Wait, what is it called?
This makes all of our sports
You know?
Yeah.
We can like make the cross country kids like power.
We bike quite, there's a lot of people biking. We can get a lot of energy.
What about a sand timer? Like the thing where you, and then the sand goes, an hourglass.
No, are you sure?
Is that kinetic energy?
Yeah, because that's movement. So if you somehow use that sand, I mean, you'd have to somehow, because once again, it's all about the sand would move something.
Right.
So maybe not just an hourglass, but if you were to make the sand go through like a spinner, like pour it onto something and it would spin it, just like a windmill.
Yeah.
Good.
Oh my gosh, I like stop mid-sentence.
Okay, second type of energy, everybody. Alright, close your mouth for a second while I'm talking. Thank you. Okay, is nuclear energy. Now, reminder, it's been a long time since we talked about nuclear, so let's just review really quick the process of fission versus fusion. Okay, so fission is the process of taking an atom and causing it to split into two smaller atoms. In that process of splitting, massive amounts of energy come out. Because there's energy, there's potential energy, like Ben said, inside the atom. Okay, and so when you open it, it's kind of like, this isn't the best, but it gives you an idea. It's like a little popper, right? You break open the atom and energy comes out. Okay, that energy then can be used, and we'll talk about it more in detail in a little bit, to then do different things. Okay? Fusion is the process of two atoms becoming one. Now here's where the popper analogy gets weird, is because this releases even more energy. Where the energy is coming from when it comes together is because when something becomes more stable, it had excess energy it doesn't need anymore, and so then it releases it. Okay? Fusion is the power of why the sun is constantly a giant fireball. Fusion is what happens inside the stars, if you remember back from that unit. As of right now, fission is what we use in all of our nuclear power plants here on Earth. Scientists have not found a way to stabilize fusion. If you've ever heard of it, whether in real life or sci-fi, cold fusion, right? Spider-Man 2 of the original series. Yeah. Anyone remembers that one with Doc Ock? Yeah. That's like what he's trying to do, is create fusion on Earth. That's why he creates like a little sun. For those of you that have seen that movie.
Heck yeah.
Okay. As of right now, scientists we don't have fusion machines because we haven't found a way to do something that hot. But if we could, it is a really cool concept because it produces so much more energy than fission does. But fission alone actually is crazy how much it does, and we'll compare energies in a little bit. Okay? Any questions about fusion or fission or nuclear? Okay, another type of energy is electric potential energy. Now the thing you need to understand about electricity is just the flow of electrons. Okay? If I had carpet right now and I went like this, and then shocked, like that, and you saw a little spark, that is literally the movement of electrons. Okay, that's all electricity is electrons flowing through a wire. Carter?
side thought, but what you just did up there made me think of this one time that me and Jackson actually did that, and we actually got like the actual picture of
Really?
the electricity.
It's so
going
cool.
between-
You
That
should
is a
show it
sick
to us.
picture.
That's
It's
cool.
so- I don't know where the picture is.
I still have the picture.
Okay, I might need to see that picture when you find
It's
it.
like
That's
Star
way
Wars,
cool.
bro.
It's so.
Is it like, so can electric energy also be like when you're in your bed and you're like moving your legs around and then you see
yeah.
like the sparks
Oh,
in
yeah.
the
Yeah.
sheet?
Yeah, I mean, in a sense, like that's not usable energy, but you're seeing electrons.
Right.
Yep.
I feel
Yeah,
so
same
cool.
idea,
It's
right?
so cool. It's like you're
Yeah.
So when it says
Yeah, it's like a
energy
all with it.
Is it blink in a weird spot?
It is
Electron charges.
It's okay.
It's like backwards up there. Isn't it?
I'm not going. Why?
Okay, next one is radiant energy, everybody.
Oh, everything.
Okay, radiant energy is the energy that's created when photons move around, and this is solar panels. Okay, because they're taking the heat from the sun, radiant energy. This is using the sun to move photons, and then that movement of photons creates energy. Okay, keep in mind the fundamental thing about energy, that there's always some component of movement going on here. It just depends on what's moving, and then how the energy is generated.
What were the examples for nuclear and electric?
Oh, so nuclear is just nuclear power plants? And then electric would just be like electrical power lines. Now, often in cases, some of these, you're going to have multiple forms of energy. Obviously, the form of energy, what's the form of energy we actually end up using? Mostly, like, we can get it from all these sources, but what do we plug into? Electric, right? So all of these forms of energy eventually get transferred into an electric form, because that's how we power our lives, right? So,
What's an example of radiant?
solar panels. Yeah. Okay, thermal energy. Okay, this is where you're using heat to power something. Anyone know an example of a way?
Hot air balloon.
Hot air balloon. Yeah, good, Tanner. That's my face for that. I didn't even pick that one. Any other examples? Ooh, I didn't think of that either, because it's like, because that's more using the heat than it is like the radiant energy. Yeah, I like that. That's a good one.
Does cooking mix count?
Pretty much, yeah. I mean, a fire in a sense is using thermal energy to cook your food, right?
Those hand warmer things.
Oh yes, those would be thermal energy. Good. Another big picture one that in terms of like powering a city is where you can actually use hot pockets under the earth, geothermal is what it's called, to actually power something. If we have time, if not, I'll show you next time. Iceland is actually really cool in how they gather and harness their power.
Really like rainfall and like very green.
Yeah, it's so cool what they do with, because of where they live and what they have, but how they amplify it, so, yeah. Okay, now here's our question, or here's how it kind of all fits together, okay? And this is kind of the big takeaway when you design your prototype for your project, okay, is that electricity is generated when we convert one form of energy into electric potential energy. So we're going to watch a little video, just one more short little video. That kind of goes over this idea of turning on a light bulb.
Here's a question for you. How many people does it take to turn on a light bulb? The answer seems simple. Just walk into a dark room, flip a switch, and instantly.
Oh.
You can see,
Oh,
right?
tell them that.
Well, the truth is, there's a lot more to generating and delivering electrical power than you probably imagined. Hi, I'm Lee Patrick Sullivan with Energy Now, and this Energy 101 video explains the system used to generate electricity. And it also explains what it really takes to turn on a light bulb. In order to understand energy, we first need to start at the source, literally. Mother Nature provides the natural resource we use to generate power. From natural gas to coal, ocean tides to mountain winds, the energy we need to create electricity must first be mined, harnessed, or collected from the earth. Some of these resources are finite, including fossil fuels like coal and oil, but others are unlimited, like solar or wind power. But a lump of coal or a strong breeze alone won't create the power that turns on your light. For every energy source, a chemical or mechanical process is required to turn it into usable electricity. Every day, researchers work to find innovative ways to use our limited.
Okay, I just want to reemphasize what he said here because this is going to play a key role. So we have these resources we can use to get energy, right? But then those resources somehow have to be used mechanically or chemically to then convert it into electrical that we can actually use, right? Because it's not like you can just plug your phone into a piece of coal and get power out of it, right? Even though there is energy inside, we have to find a way to get that energy.
To resources, process raw materials, harness renewables more efficiently, and find entirely new energy sources. Today, the majority of America's electricity comes from thermal power plants. Fuels like coal, natural gas, biomass, and uranium are used to heat water until it produces steam, which powers a turbine and generates electricity. That steam turns propeller-like blades around a rotor inside the turbine. This turning rotor connects to a main shaft which spins magnets with a coil inside a generator. It's the generator inside a turbine that converts mechanical energy into electric energy and creates electricity. Steam is an efficient method of producing electricity because the water can be recycled and reused as it changes back and forth between liquid and gaseous states. Transporting electricity from the power plant to your home is an entirely different process. Current technology cannot cost-effectively store large amounts of electricity, so significant challenges exist when it comes to transferring that electricity across long distances. Just enough electricity has to be generated to meet demand at all times and be transmitted through power lines to reach your light switch. Too much or too little power can crash the transmission system and cause a blackout. That's why a complex mix of logistics, management, and infrastructure is needed to transmit electricity from power generators to consumers. Enter the electricity grid, also known as simply the grid. The North American electricity grid is actually made of 4 large grid systems: the Western grid, the Eastern grid, the Texas grid, and a grid covering the Canadian province of Quebec. These independent regional networks of power plants and transmission lines carry electric energy at high voltage within their area to local utilities. There are very limited links between the 4 grids, which means electricity generated from a wind turbine in West Texas cannot reach an apartment building in New York City. For electricity to move through one of the 4 grids, its voltage must first be increased by a device called a transformer. Then the electricity can travel long distances across high voltage transmission lines. These high voltage lines are generally strung between giant metal towers. They stretch for miles from power plants to local substations in each neighborhood. You've probably seen substations along the side of the road and wonder what they do. Well, their job is stepping down electric voltages from levels as high as 765,000 volts closer to the 110 volts you use in your home. The electricity from the power line on your street passes through another transformer, which steps down the voltage once more, and then it travels along the line into your house. From there, the electricity enters your breaker box, and it is then distributed to light sockets and outlets. All you have to do is flip a switch. So, as you can see, from the raw materials to the power lines on your street, there's so much more to the electricity ecosystem than meets the eye.
Okay, any questions that came to your mind as we were watching that? Yeah, Ellie.
So how many people does it take to screw the light bulb?
I know they didn't actually answer the question.
Three?
I mean,
The power plant and then the transformer,
A lot
the
more than
transmission,
one.
and then.
but there's like, yeah, I mean, there's a lot more than like 3 people at a, you know, or like they have to go gather the coal. I don't know. I thought that too after, and I was like, wait, you didn't answer the question.
We made a guess and everything, like we were guessing.
Really?
At least 5.
Yeah, because you have to have someone, I mean, I guess if we really simplified it, right? You have to have someone to gather, if we're doing coal, for example, right? Somebody has to mine the coal, and then someone has to burn it to produce the steam and the generator, and then you have to have like the transformer person, right, who helps it transfer, and then where they bring the power back down, and then you turn it on. I'd say maybe 5.
I guess if you were really efficient,
So,
that
like-
could all be one person.
Yeah, like
So
super
really,
simplified.
One person could just do all of that, and it just wouldn't work very well.
Yeah. It would just take a lot of work to do so. Good question though. Any other questions that came up as we were watching that? One that I thought was interesting, and I was curious your guys' thoughts. I looked up the answer because I wasn't sure myself. Anyone have a guess of why Texas has its own power grid?
It's so big. Just in case.
So I heard some because they're so big.
Just
They what?
in case they bite off and go to the
So they have their own energy. I did think it was interesting, and I don't know for sure. And it's really actually because of, back when the power grids were established, Texas wanted to be their own thing.
I think it's a good thing.
It's really just Texas.
Well, I know, it makes me think of like with what happened this year at Texas. I'm like, man, if they didn't have their own grid, would that have spread more? Or would it have helped, right? I don't know. So, okay, turn the page over and let's talk about your project, everybody. Yes. Okay.
There's no love in this packet.
No.
I'll be an investor, I can do the money, you do the it's just like real life.
Okay, sorry, here's my page. Okay, so this project, I will say, is primarily independent. Independent in that your grade is determined by you and you only. Now there is a partner associated with it in that you will be debating your project against somebody else. Okay, so 2 people will be assigned the same scenario. You'll each pick your own type of energy source that you think is best.
And they have to be different.
They do have to be different, so whoever
Interesting. So
picks
whoever
first.
plays in that.
Okay, and then you will debate as part of your presentation of why you think your proposal should be the one picked. Okay, but once again, if the partner you're debating didn't do their research, it has no impact on your grade. Does that make sense? Okay. Okay, so here's the basic idea, and this is really what most of our unit will be spent on, is just working on this project. There is a day next week where we'll do a little lab and talk more about batteries and how they work. And do a little where we create some batteries in the lab. But then outside of that, it's mostly just going to be working and preparing our projects and our debates. Okay, so I'm just going to go through this really quick, and then if you have any questions after I'm done, we'll answer them. Okay, so our goal is to understand sustainable energy, how it works, where the energy comes from, and why it's considered sustainable and more. Okay, each group of 2 partners will design a solution given an energy problem. The energy problem will be presented to you as a scenario describing a business that wants to hire you. You and your partner will each choose a different source of energy that could work for your scenario. Once again, with those different examples we went through. Okay? Then you will each research your chosen energy type and create a debate on which source of energy is the best option for your scenario. You will then use your research to design and build a suitable prototype to address the concerns in the scenario. Okay? So in the end, this is kind of what you're going to need. Number one is a filled out research packet, which is the pages that follow. Okay, that's kind of your homework for the unit. It's pretty much where you'll just take all your notes. It helps you think through what you need to think through for your actual presentation. Okay, you will create a poster presenting your proposal, saying like, I think we should use solar power and this is why, right?
Could we use a PowerPoint instead of a poster?
Sure, yeah. We can even change that to just somehow present it with some visuals. But yeah, if you want to do computer instead of on paper, totally fine with that. Okay, you do need to have a drawing of your prototype to help make sure we understand that you understand the energy flow. What I mean here is you're not coming up with a new solar panel, right? That would be crazy. I mean, if you can, that'd be awesome. But you're just going to make sure you can explain how a solar panel works. Okay, meaning the energy comes here, it does this, right? That whole idea of the energy transfer. Now your drawing doesn't have to be just like totally by hand. It can be pictures that then you put arrows and things on so you could print things out if you're not an artist. But if you want to draw it by hand, you're totally welcome to. And if you come up with some sort of 3D model of it, that's where you can get extra credit on this presentation. So if you want to build a prototype of a solar panel or windmill or whatever, and any type of whatever popsicle sticks you want to use, you get some extra credit for it. So, any questions about the project? Yeah, Jeremy.
Like the debate just have to be about I don't know, the energy sources itself. What I'm kind of trying to say is can you take into account other parts of the business to debate?
Yes.
There's outside reasons other than just it produces the most energy for the cheapest?
For sure. Because what you'll see in the scenarios too is that each scenario possibly a certain choice might be better than another because of it. Because of what's available or what's not available. Like one of the scenarios is building a colony on Mars. Right? And there's only so many resources on Mars. So yes. Yeah, it's not always just about because straight up, right, nuclear produces more power than the rest of them. Hands down. But it doesn't mean it's always the best choice for what you're trying to accomplish. So, yes, for sure. And I'll kind of go over the debate breakdown maybe next time or the next once we get a bit closer. It won't be very long, so you have to kind of time out what you want to say and as well. So, did I answer your question, Jaron? Okay. Any other questions for now about the project or presentation? Okay. I guess I'll give you, maybe we'll hand out scenarios today. So you can there's really no set homework because all of next time we'll be working on the project. But maybe I'll hand out your scenarios today and then that way you can be thinking about it. So everybody needs a partner. Everyone want to just do their table buddy and then Benson will find you an imaginary partner for now. Does that work? Is that okay with everybody if you debate your table buddy? Yeah? Oh, by the way, after the debate, the class will vote on which proposal they like, and that person will also get extra credit, whoever wins the debate.
Wait, did I? Okay, sorry, what did you say?
Whoever wins the debate also gets a little extra credit. Extra credit.